I'd like to apologize for last week's recording. Unfortunately, we had some technical difficulties, and the audio was muted on there. Hopefully, I can cover some of the material that was done there, and I hope you will be able to learn from this particular session. I just want us to take a look at the syllabus really quick because all projects are due on the deadline. The last day of class when projects are due is December the 17th. So if you include this session, this video along until the 17th of December, we have approximately 5 altogether. It's going to comprise of 5 sessions. Okay, so what folks should be doing is basically shoring up or finalizing some of those projects. We need to be on Sakai at least 3 times a week in order for you to get credit for the attendance. If you haven't done so, you need to basically contact me, whether it's on Sakai or whether you call my phone number. It's all that information, that communication needs to take place. Be sure to contact me. All that information is online. Okay? And today, I want to take a look first at the 4 next loop because Project 7 and Project 8 both require you to have an understanding of the 4 next loop. I had basically covered it in a previous session, but I want us to take a look at it again because it's vital in writing these 2 projects that's necessary. These projects are on page 270, 255, and 251 to 252 of the class. Okay? And if we go to page 230, all right, let's take a look at open the text. I'm going to go to page 230, okay, and I'm going to see the basic form of a 4 next loop. And what a 4 next loop is going to do for us, it's basically going to execute statements within the 4 and the next statement a certain number of times. It's going to do it more than once. How much is going to be repeated? If you look at the general format of it, we're going to see that we say for I, which is the initial, the counter variable. This is going to determine how much I'm going to increment my values and how many times. It's just going to be it's just a counter. How many times is going to be executed, and what would be the interval? How often is going to be executed? Has to do with the initial value and the terminating value. Okay, so the terminating value tells me when it's supposed to end, and all the statements as we go from the initial value to the terminating value is going to tell me how many times these statements are going to be executed. So as I move right along, I don't want to get into the pseudocode and the flowchart. If you were to look at this particular example, a counter variable can also be declared with a dim statement outside of the 4 next loop. For instance, the following program produces the same output as the program shown in the beginning of the section. Okay, so if I wanted to create this, and this particular reason why I would do it is because for those people who are still having difficulty creating their own programs, I'm going to work in reverse, or I can work based on what I see. What I'm seeing right now is that I have a button, and the name of the button is display. So on my form, I'm going to have a couple of objects. One is going to be a button. And how do I know it's a button? It's BTN. That's the prefix, right? What's the name of the button? It's going to be called display. Okay. I'm also going to have a list box. And the name of the list box is called table. So you're going to print something that looks like a table because it's going to have a couple of columns, it's going to have a couple of rows. In this case here, it's going to have 2 columns. One column is going to be the numbers from 1 to 5. And I can easily extend that to 1 to 20, 1 to 100. And in the second column is going to be the square. Okay, so I'm going to put the number, and then I'm going to put the square of the number. Not the square root, but the square. Okay, for example, 1 is 1 squared. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. Okay? So that's what we see. So if I wanted to go to Excel, I always like using Excel because I think Excel makes it a little easier for you to understand, because Excel has a built-in math function, which allows us to do, like, for example, repetitive statements by using formulas. So I'm going to say number, and then I'm going to say square. Or I can put square of number. Okay. And if I do this once, the square of 1 is going to be equal to, I'm going to use a reference of B1. I'm going to say equal. I'm going to write a little formula here. Equals A1, A2. Okay. Caret symbol. Caret is shift 6. That's going to give me same thing as finding the exponent for the square of a number. It's 1. Now, I'm going to write 2 in Excel. But Excel is pretty smart in that I'm going to select these 2 values. At least if I got 2 values and I used to use the autofill, I can go right down here to 5, and then I can do the same thing right here, right? I can use an autofill, right? So there we go. This is what my answers are, so I have to be right. So if I were to do my this particular state program, very nice and simple, but yet still it's necessary for us to understand when we do the projects in chapter 6. Okay? So if I'm going to start Visual Basic, and I'm going to go New Project, and I'm going to call that Square of the Numbers. Okay. This doesn't have to be that big. Okay. I'm going to call this form FRM square okay, and on that form, the text on there is going to be squares I want I can make this a little wider so I can see that. Okay, and I'm going to have a button on there and a list box. This is a button. This is a list box. And my button is going to be called display. So I'm going to scroll right up here. It's going to say display squares. Or I could say, let's just say display table. Okay. And I'm going to give it a name. BTNDISPLAY. Is that what they call it? Let's just see if that's what they call it. Display, right. There we go. And the list box is going to be called LST table. Okay. So I'm going to double click on here. Right. I'm going to see the header for the button. My event is going to occur when I click on the button. And let's go right to the text. And I can okay, I can select everything here. So I'm going to take this part right out here. So I want to display a table of the first 5 numbers and their squares. Assume the font for the list table is Courier New. So let's go do that. I'm going to take out this right here. I'm going to save all. Okay, we do have some errors here. Let's just fix the errors. List items. List items that add. This would be shift 6. There we go. Now it's all set. We don't have any errors. We want to save all. Okay. Div is an integer. I'm going to set I as an integer from 1 to 5. Initial value, terminating value, counter value. Okay. And what do I want to do is to print each one. And I want to make sure that my list box font, that font has to be what? Courier New, the font. With the font, and we want that font to be Courier New. To see how it looks. What did I select? Courier New, 12 point. That's all I did. Okay, I'm going to save everything again. Okay, and let's just see how the program runs. Let's play the button, and there we go. 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. Notice that the column starts right there, right? Sounds good, looks good. All right, we can stop the program. All right, so we got an example of what the for next loop can look like, right? If you want, you can look at simple projects, like in this particular project here, project 6.1. Suppose the population of a city is 300,000 in the year 2010, and is growing at the rate of 3% per year. The following program displays a table showing the population each year until 2014. Okay, and this is what it looks like. Okay, let's just go quickly run this program. This is example 6-2.1. 6.2.1. From our sample programs, we have 6.2.1. So I go to source code, I go to programs, I go to chapter 6, I go to 6.2-1, and I open up the Visual Basic project file, and click OK. It's a trustworthy program format population. Okay. I want to take the code. If we look here, we can take the code exactly the way it is. Okay, I'm going to display population from 2010 to 2014. Let's just say I want to change it to 2018. I can make that change in 2018, and I'm going to go to 2018. Okay, and if I were to look back at my table, I might want to make my table bigger or a little wider, I should say, and make my form or my list box a little bigger. And now if I run the program, display the population. Okay, 2010, 2011, 12, all the way to 2017. I'm going to grow by 80,000 people. I'm going to have 80,000 more people by 2018 with this population growth. Okay, take a look at the coding that coding that was done for year as integer. Okay, in other words, dim population as double is equal to 300,000. That's the initial value. Okay, the year is going to be an integer. 2010 to 2018. Okay, it's going to basically, in the list box, it's going to print the year, right? Whatever value the year is going to set, right? And it's going to be format population, right? Format pop, okay, which is 300,000, comma 0, and then you're going to say population plus equals. That means it's going to take the population and add 0.3, which is 3%, times the population, okay? And it's going to keep incrementing each time, okay? Hoping that you understand that. Okay, let's now take a look at the project. Let's now take a look at another project, which is one of the required projects. So if I go into Sakai, go to Sakai, and in Sakai, I will go to assignments, and project number 7 I'm going to start with project number 8 first. Project number 8, which is the rule of 72. So I can download this program. And I'm going to download the Excel sheet that I gave you. Let's just take a look at the Excel. So rule of 72 states that, if you make an investment, or if you look at growth in most cases, growth, what's going to happen is that if you have some money that you invested, as an example, and you were to get an interest rate of, say, R, then that money that you invested is going to double in 72 over R years. Okay? So we're going to look at it from that perspective. We're going to look at it from, as the text said, I'm going here to page 276. And on 276, the rule of 72 is used to approximate the time required for prices to double due to inflation. If the inflation rate is 5%, then the rule of 72 estimates that prices will double in 72 over R years. For instance, at an inflation rate of 6%, prices double in about 12 years. So what you have to do is to write a program to test the accuracy of this rule. For each interest rate from 1 to 20%, the program should display the rounded value of 72 over R and the actual number of years required for prices to double at an R% inflation rate. Assume prices increase at the end of each year. Take a look at figure 613. Figure 613. Okay? So, what can we do here? Let's just take a look here at the rule of 72. Well, the actual rule, the rule of 72 states that 72 over R, if R, the interest rate, or I should say, in this case here, it's not interest rate, but you could also use inflation rate. Okay? Inflation rate slash interest rate is going to take 72 years. Okay? Actually, this is the little rule that we use here. If we use a natural function, ln of 2 divided by ln of 1 plus a over 1,000, that's this equation here, you will get 70. Okay? If I were to do it for 2, it's going to be 36, right? So on and so forth. So this is going to be pretty much steady because it's just 72 divided by the interest rate. But what we're going to notice is that the actual value is rounded, because if I were to expand it, see that? I'm rounding it. When I round it to the nearest ones, it's going to give me 70. When I round it to the nearest, if you take a look here, they ask you to round. Write your program to display the rounded value and the actual number required for prices to double at an inflation rate, right? So this is what we're going to have to do. Let's take a look at what I gave you. Project number 8. I put it on there. See over here, project 8. So if I expand it, I should have a project 8, rule of 72. I'll look at the Visual Basic file to see what we have here. Okay, so you should make this a little bigger, make that a little longer. Okay. In this case here, what you would have to do is to calculate the rule of 72 using the formula 72 over R, and T is equal to the natural log of 2 divided by the natural log of 1 plus R over 2. So you got to keep in mind that R is a whole number. To not convert R to a percentage, make sure that it's a whole number. Okay? Once you have completed that, right, you're going to print the values in the list box, right? And an example could be to create a list box called output, and then you're going to say the rule of 72 doubling time, colon, right? And you would put the value for the output right here when it doubles. Okay? You should have one or two lines for that. Okay? Now, within this particular code here, we can also include a for That means continuation. You put the statement, and then you'd have a next. So you got to make sure that you have that for next loop. Okay? You could also use do while within while these what statements here executed because of the fact that you're going to have to print both the doubling time and the actual doubling time, the rounded doubling time and the actual doubling time. You can have these statements could include a do while continuation. Make sure you end that up with a, you're going to put statements there too. Okay, so that's not going to work here. You can't put any spaces there, but you, within the for next loop, you could have a do while. So these statements that are going to be executed here, okay, I guess we can put these statements right about here. Okay, but we got to make sure that our next is for the for and the loop is for the do statement.
This conference will now be recorded.
Now, if you look here, the code can get a bit complicated, right? So we have to be careful with this loop, this do while loop. This do while loop is going to be used to give us the actual years it would take to double. Okay? And if you go back here into our program, into our text, what would it take? How can I write code that allows me to show when this particular interest rate will cause prices to double? Okay? It's pretty straightforward with the other one, right? The rounded value, I'm just going to take 72 divided by the interest rate, and I'm going to round that value. So I'll only take the whole value. Okay? Let's just see if the text has anything that can assist us with finding.
This conference will now be recorded.
That can help us basically write code for the doubling of the value. Okay, doesn't seem like we're gonna get anything here. If we go look at, let's see if there's anything here. And be careful to avoid. If we look here, two balanced wires at less than 1,000. Let's just take a look here. Example 5, suppose you deposit money into a saving account and let it accumulate at 6% interest compounded annual. The following program determines when you will be a millionaire. Okay, this is 6%, this is 1%, I'm still looking. Hi. Well, to make stuff a little easier, what I'm going to do, I'm going to write some code. So I can take a look at this one right here. And I'm going to change this text box to a list box. And what I'm going to do is display these numbers. Okay. And I'm going to use the list box right here. Okay. So we're going to have a button, a list box called output, and a button called display. And we're going to actually see what happens during the course of, I'm going to use this particular example just so you can see what happens within a do loop and if I'm incrementing that do loop multiple times. Okay? So what I'm going to do is I'm going to take this small do loop right here and I'm going to do that 4 or 5 times. Okay, so I'm going to start a new project, file, new project. And I'm going to look here. It's going to be exercise 6. Exercise 6.1.3. Okay, that's what I'm going to call it. And I'm just going to have a form. I'm going to add a button. I'm going to add a list box. And on here, I'm going to put exercise. Button display. We're going to call that display. I'm going to call this output. Okay. What kind of code am I going to put on here? I'm just going to copy the code. Dim total as 0. That's the initial value. Dim num as integer equal 1. Do while num is less than 1. I'm going to say total is equal to 1. Right? So I'm going to print num and total. And then what I'm going to do, I'm going to print it to the list box. So I'm going to take one of these out. And I'm going to print that to, okay. This is going to be LSD output dot items dot add, and I'm going to put what should I put in here? I'm going to put num, comma, ampersand, no, I should say num, ampersand. Num ampersand, total. Ampersand, and I'll put total. So this should only print once. If I run it, it should just only print this once. Save all. See, that's a value of 5 and 10. That's the last value. It's going to go up to 5, and it's going to give me 10. So I'm just going to add each value as I go. So it's going to start with 1, then, so let's just go stop this program. And I'm going to take this loop. I'm going to put the list box in here because I want that list box to be repeated more than once. I want it to print in the list box each time. Okay, so let's run the program now. Okay, so let's see what happens there. It started out as 1, then when it ran num, is num, first it's going to look, is num less than 1? Yes. Is num less than 5? If the answer is true, then it's going to say total. Okay. So I'm going to, before I continue, I'm just going to make a little change here. So I'm going to take this statement right here, copy it, and I'm going to put it right after here. Oh, I got to stop the program. I'll call this num. Excuse me. And I'll call this total. Okay. So let's just run it. No, I didn't went to, I don't need loop in here. Let's run the program now. Okay, let's do this again. what I'm going to do, the list box, I'm going to change the list box font to Korean New. Okay, modifications. You want to make sure that we understand this. Okay, so what I'm going to do, actually, just add some space. Okay, good. With that program again. Okay, good. That looks better. All right, so let's just evaluate the output. The output is initially total is 0 and num is 1. Okay? So num is 1, total is 0. So 2 while num is less than 5. Remember, num is 1. When num is 1, okay, what's going to happen? Total is going to be equal to 1, and num is going to be incremented by 1. So num is going to be 2, total is going to be 1. Okay? When we go to num is now going to be 3. The total is going to be 1. I mean, plus num is now going to be 3. It's going to be 2. Total is going to be 2 plus 1, which is 3. Right? 3 plus 1 is 4. When num is 4, right? This is already incremented to 2 plus 1, 3 plus 3, which is 3. 3 plus 3 is 6. 6 plus 4 is going to be 10. Okay? So, when is this number going to double? I can keep increasing it. I can say, okay, look, let's go to, well, look, it doubled right here. Right? 5, this number doubled. Okay? So I could write this little do loop here with this little increment right here. I can take this do loop and it can tell me that, look, when I do this particular code, the number is going to double. Okay? When num is equal to 5. Okay? So I could utilize this type of code in my program itself. I can copy and paste this loop that can determine when my number doubles. So let's just take a look how we could implement this to determine when a number can double. So I'm going to call total is going to be this right here. Okay. Now, if you notice, Num is incrementing each time. Num is only incrementing by 1. Okay, so let's just do this. Let's just convert this now, and we're going to add a 4 for I for num as integer, and we're going to say equals 1, 2, 5. And I'm going to put a next right here. Okay, so notice what it does for num as integer. So why am I getting variable num hides a variable in an enclosing block. So I could say dim num as integer right here. I could take this out. There we go. Let's see if this program can run now. Modification. Okay, look at what we got. We got the same value. We have 2, 1, 3, 3, 4, 6, 5, 10. So what this shows is that I can take this and I can create a method to determine when my value doubles. Okay, once I write this code, I should be able to utilize it, right? I modify this code with both a for and do loop, and I was able to come to conclusion that I can write this code to show when a value is going to double, right? Okay, so folks, please try your best to contact me. I will be looking forward to hearing from you. I hope that this was helpful in terms of you completing your projects. Again, if you have any questions, please do not hesitate to contact me. The time is getting very close to the end of the semester, so don't wait till the last minute because it would be very difficult. All right? All right, I will leave you. Have a good night, and I will see you guys next week once again.